So if you want to focus on limit cones, something like this, okay? So if we're on a limit cone, I can show you how it traces out negative, positives, negatives, all the way around. Is that the one that we just did? Okay. Now, when we do this and I turn it to a plus, what switched? Every color, but the shape was the same. So look, when I go back in time, start here. Now I'm positive until the negatives, then to the positive. Okay? And then we had a big talk. I'm going to rearrange it. I'm just going to write 3 plus sign. Okay, that's the same guy. What I care about now is I want you to notice if it's a plus 6 sign versus a minus 6 sign, the idea of it flips up and down. So what does it what happens to the guy if you flip the sign with the trig guy? This versus this. That flips what? Like the whole graph. But then what happened if I switch the 3 from a positive to a negative? It changes the color, which means it flipped the radiuses, but it's still the same shape. Now what happens, I'll turn off for a second, and I make this plus 6. Oh, I thought I turned it off. Oh, wait, let me turn it off this way. 6 cosine. It's going to have the same feel as the sine guy, but it's going to be looking right and left rather than up and down. Since it's a positive 6 cosine, it's going to be focused on the right side. Okay? And if I made it a minus, it's now focused on the left side. Because, okay, it's kind of that idea. Then what happens if I don't make this a 6, I make it a 4? Do I still have a loop? I make it a 2. Why do I not have a loop? Because who wins? 3 or the cosine dude? The 3. Do you see how that always stays positive? Give me one that doesn't make a loop but doesn't look like this, but it almost is the in-between. 3. Do you see there, right there's the moment where it wanted to loop, but it didn't. So it would be awesome for me to animate that with an A. And look how I can make the loop. And you'll notice the looping happens when I match the number right here. I'm matching 3 and 3. Who cares about the plus or the minus? I'm matching it so it's like a rounded heart. And then when I make a bigger negative, I got the loop. If I make a smaller, no, back to here, and then I can loop it. Does it make sense that when A is 0, what do I have? Circle, because what happened to the whole trig dude? He's gone. You guys okay with that? Okay? So that's a way to play with kind of trying to understand how things look. Okay? All right. This is kind of cool. This was when we were pregnant with Michael. This is how I released it to my students here. Pregnant with Michael. Cool story. And now we have Michael and Marianne. Crazy how time flies. And this is the story how I got a Nintendo, which was really cool too. And the kids were super pumped. Nope, because I'm on video. Okay. So, plug and chug. Easy. Think and link is the stuff that's going to take a while to look at. How do polar graphs look? What happens inside the looping of polar graphs? That's what I got to spend some time on, which is the whole idea of the story. Stories are harder to interpret because you're not used to telling the story. Think back to the parametric when I was like, am I going clockwise or counterclockwise? Do I start up north or south or east or west? How fast is Lightning McQueen going? That took you a little bit of time to go like, Bach, it's a circle. I go, I don't care, it's a circle. How did you drive on the circle? Remember that last week? That's a think and link because it took you a little bit of time to understand how to tell which way you're going. Okay, so here's one. Think and link. I want to look at dr d theta, and I want to know when is the Chomper chain extending or shortening. Okay, I'm already showing you r, and I'm showing you dr. d theta. How's that? Okay, is the derivative easy? Is that a plug and chug just to get the derivative? Okay, but here's my question to you. Just because dr d theta is positive does not mean I'm getting longer radiuses. I'll say that again. Just because dr d theta is positive does not mean I'm getting positive or bigger radiuses. What's the key to it? I'm increasing my Chomper chain because why? dr d theta is positive and what? And what's the radius? Which is, look at my green. What's the radius? Positive. What's dr d theta? Positive. That means I'm extending my Chomper chain. Here, I'm shortening my Chomper chain. Some of you go, yeah, that makes sense because you're really focused on the reason you think it's shortening is because of this. It's not because of that. Why is it shortening? Because the radius is positive and I'm decreasing the radius. Think of numbers that start positive and decrease. 8, 7, 6, 5, 4. Is that a decreasing Chomper chain? Think up here. Why is this extending? Because my radius is 5, 6, 7, 8. Do you see how I'm extending? What's going to mess with you is these. Why am I actually getting my Chomper chain shorter? Yeah, whoa, be careful with that. So JJ said I'm starting negative and I'm increasing the negative. I know what he means by that. Do you agree it's always weird when we talk about increasing and decreasing in the world of negatives? So I'll count it for you. My Chomper's at negative 10. Now count. Negative 10, negative 9, negative 8, negative 7, negative 6. So am I a red Chomper that's getting shorter because I'm trying to, think about like you're diving in water. You're trying to rise up to the surface. I'm below the water. My radius is negative, but my radius is getting shorter because I'm going negative 10, negative 9, negative 8, negative 7, all the way up to 0. 1 second, Luke. And then here, if my radius is negative, negative 10, and dr d theta is also negative, which way do I count? Negative 10, negative 11, negative 12. So that's a red radius that's growing. Does that make sense? So a question on a test is going to say, when is your Chomper getting closer to the origin? Rephrase that. When is the Chomper getting closer to the origin is asking for, when is the Chomper shortening? Do you just get a look at when dr d theta is negative? No, what do you have to look for? When is the dr d theta and the r opposite? If I ask you, when are you running away from the origin? When is the Chomper trying to reach past the origin and go further away? That's when your dr d theta and your positive. Or when dr d theta and r are negative. So I could draw one. Let me just draw one back on this guy. Let's look here. Okay, talk me through it. Okay. In the red world, all my r's are negative. What looks like my r's are doing? My r's are getting smaller, which means what? That my Chomper is getting closer to the origin. Now look. That was this section right here. I was big, smaller, 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 0. Now let's look at the blue loop. What happens in the blue loop? First thing, what's all my r's? Positive. Where am I growing? The first half, because my dr d theta is increasing. So the first half of the loop, I'm growing away from the origin. Second half, I'm shrinking. Look at it on the blue loop. First half, I'm growing to here. Then I am decreasing. You guys okay with that? Hey, one more thing. I just want to make sure this is a clarifying thing. So if I want dy dx, okay, and I told you yesterday dy d theta over dx d theta. If you look in the book, it really confuses you. If you heard me wrong yesterday, it can confuse you. I want you to treat this just like parametric. Parametric had the same flow. What was the parametric flow? dy dt over dx dt. Because parametrically, do you agree you had an x thing in terms of t and a y thing in terms of t, and it was easy? Good with that? Okay, clarifying, because some of you heard me wrong yesterday, or if you were in second hour, you heard something different. dy dt dx dt, you can do parametric. What's weird in the polar right now? What do I not have? The x and the y. Do you agree? Parametric, it says x equals y equals. Polar, it's like, no, polar is r equals. But what's the fact about x in terms of r's? X is r cosine theta. Y is r sine theta. And what does r mean? Is it just the letter r? Or is it the dude? It's the dude. It's the function you're referring to. So I can write this as 2 sine 3 theta cosine theta. And this can be 2 sine 3 theta sine theta. Notice how it is r times cosine, r times sine. Now do you understand polar derivative better if I want dy dx? Can you just take this guy's derivative, which would be a product rule? Can I take this guy's derivative, which would be a product rule? Can I put this guy here? And can I put this guy there? Okay? So it's like, make it parametric by doing the r cosine, r sine. And then from that, you do it just like parametric. If I ask for when is the slope flat, who do you care about? When is the dy dx flat? When am I moving west and east only? When top or bottom equals 0? Top. When am I moving north and south? When am I going vertical? When is the slope of the tangent line undefined? It's when the dx d theta equals 0. Just like we did with parametric. You guys good with that? Things that you might want to look at a lunch, or lunch today I'm doing the National Honor Society trivia thing, which a lot of you might be doing, so I'll be there at lunch. But you could do this at lunch. I'll post the notes. You could also do this at home. Do you see how I'm trying to just say, hey, who am I and how quick can you tell me who I am? Did I already kind of show this on the Desmos maybe 10 minutes ago? Do you see these are the limicons or the rounded hearts or the dimples or the loop-de-loops? And it's all depending on how big the numbers are in front of the sine and the other number, or the cosine and the other number. Okay? Cosines are focused on the x-axis, sines are focused on the y-axis. Okay? Okay, another thing that you could do at lunch/home, and what do you think's right behind this? Answer key. Okay? And I'm now going to do some area stuff. Here's my area stuff that I want to talk about. I'm just going to give you the formula right now. Okay? Instead of me proving it to you, why don't you just write this formula down? Area and polar is all about angles. And you care about when you go in and go out of loops. And the formula is 1/2 r of theta squared d theta. In a quick nutshell with 30 seconds of explaining, it's on the previous page, but when you did area in rectangular, it was just f of x dx, because you were doing heights times widths. And that found you the area of a little rectangle. The whole idea in polar world is you're not doing rectangles, you're doing little, see if I can move this. You're doing little slivers. And the question that some of you might remember from geometry is, what's the area of a sector? And with 3 seconds left, the area of a sector is